Standard deviation and variance. So we're going to be having a look at how to calculate the standard deviation and variance of a data set, and then interpreting it and having a look at what it actually means. So to start with, we have got two frequency charts here. On the left-hand side, we've got the distribution of IQs in year 10 and the right-hand side in year 11. I want you just quickly to jot down in your blue book or just on a piece of paper, what's the same between these two graphs and what's different? Both classes have got the same number of students. Okay, so write down what's the same, what's different. Okay, so looking at these, the mean is going to be the same for both classes. Okay, we can see that it's pretty evenly split down the middle, half on the left, half on the right. The range is going to be the same, 140 to 90. Okay. The overall spread of values is going to be greater for the second one because there's more data further out than there is on the first one. Now, we could show that with the interquartile range, looking at where that 25th and 75th percent of the data is going to be. But we want a method that takes into account all the values, not just ignoring those at the extremes. So to do this, we have the variance. And the variance is a measure of spread that takes every single piece of data into account. By definition, it's the average squared distance from the mean. Okay. So if we take that phrase, the average squared distance of the mean, that definition, okay, we can write it down as a formula. We're going to use the Greek letter sigma, or lowercase Greek letter sigma, squared to be the variance. Okay, and you'll see why squared in a bit. So x subtract x bar, x take away the mean. So each value taken away the mean is going to be the difference from distance from the mean. Okay, we want the squared distance from the mean, so we'll square it. Now we want the average, so we're going to add all those up for every single value and then divide it by n. Okay. So this is a formula for the variance, but it's a bit of a pain where we have to work through every single value every time. So rather than using this formula, we're going to use a different one. Okay. If you want to have a go, you can simplify it. It looks something like this. So if you want to do that, you can, but you don't have to. The way that we're going to look at the variance is that it is the mean of the squares, subtract the square of the mean. Okay. And if you can remember this phrase, then you will be able to remember the formula. Mean of the squares minus the square of the mean. Okay. Now, I did mention standard deviation as well. So the standard deviation is the square root of the variance. That's why we use sigma squared for variance, because then standard deviation is just sigma. Okay. And we can sort of roughly think of standard deviation as the average distance from the mean. But of course, that's not very exact. So let's have a look first of all at some examples, and then we'll have a look at interpreting it. So the variance, first of all, always start off working out the variance, then we can square root at the end. So we've got two pieces of data here, 3 and 11. It's going to make our life nice and easy. We can see exactly what's going on. So we're going to do mean of squares, which is going to be 65. Take away the square of the mean, so 7 squared. That gives us 16. And our variance in this case then is 4. Okay. For the one on the right-hand side, if you want to pause the video, have a go, see if you can work it out. So the mean of the squares, so square them all, find the mean. Subtract the mean squared. Okay, so we'd have 19.2, subtract 4 squared gives us 3.2. And again, we can square root it to give us our standard deviation, 1.79. Okay, give these two questions a go. See if you can work out the variance and standard deviation. Remember, variance is the mean of the square, subtract the square of the mean. Okay, let's go through these then. So the first one, we want the mean of the square numbers. So we're going to square them all. 2 squared plus 4 squared plus 6 squared, divide by how many we've got is 3. And then we're going to subtract it by the mean, which is 2 plus 4 plus 6 divided by 3 squared. 2 squared is 4. So we've got 4 plus 16 plus 36 divided by 3 minus 12 over 3, which is 4, so 16. Okay, so there's 20, 56 over 3 minus 16, which gives us our answer of 2.67. Our standard deviation and square root of that is 1.63. Do the same thing for the second set. Variance will give us 2, and our standard deviation 1.41, square root of 2. Okay. So, as I say, this is really important that you can just remember this phrase: the mean of the square, subtract the square of the mean. Okay. You don't have to worry about the numeric MSMSM. To be honest, for me, that would just confuse things. Just remember mean of squares, subtract the square of the mean, and then we can write down what it's going to be. Here's just another way of writing that. Hopefully, might make sense for a frequency table when we have to multiply our frequencies by the value squared, divided by the sum of the frequencies, and of course, taking away the mean squared there.